Hello everyone. In our last module, we are going to explore statistical relationships, which is a core concept in econometrics. We are going to cover how to understand different variable types, how to interpret correlation, and the fundamentals of hypothesis testing. A key takeaway from this module will be the crucial distinction between correlation and causation. A statistical relationship refers to a pattern or association between two or more variables. These relationships can be observed visually, as in a scatter plot, described verbally, or tested statistically using various techniques. Identifying and analyzing statistical relationships is central to drawing conclusions and making predictions in economics. For instance, we might observe a statistical relationship between education levels and income or between interest rates and investment. To understand statistical relationships, we need to distinguish between different types of variables. The dependent variable is the variable we are trying to explain or predict. It is the outcome variable. The independent variable is the variable that is believed to influence or explain the dependent variable, and it is also called the predictor variable. Control variables are variables that we include in our analysis to account for other factors that might affect the dependent variable, thus isolating the relationship between the independent and dependent variables of primary interest. Let's consider some examples in economics. Income is often considered a dependent variable, as we might want to explain what factors influence a person's income. Education level is frequently used as an independent variable to explain income, as higher education is often associated with higher earnings. Age and gender are often included as control variables in income studies to account for the fact that income can vary based on these factors, independent of education level. Correlation is a statistical measure that describes the strength and direction of a linear relationship between two variables. It is important to emphasize linear because correlation only captures linear associations. The correlation coefficient, which is the measure of the strength of correlation, ranges from -1 to +1. A correlation of +1 indicates a perfect positive linear relationship. As one variable increases, the other increases proportionally. A correlation of -1 indicates a perfect negative linear relationship. As one variable increases, the other decreases proportionally. A correlation of 0 indicates no linear correlation. The variables are not linearly related. However, it is crucial to remember that a 0 correlation does not necessarily mean there's no relationship at all. It simply means that there is no linear relationship. It is important to remember that correlation does not equal causation. Just because two variables are correlated, it doesn't mean that one causes the other. There might be other factors at play. A third variable, known as a confounding variable, may be influencing both variables, creating an apparent correlation. For example, ice cream sales and crime rates might be positively correlated, but it is more likely that a third variable, like temperature, influences both. It is essential to always investigate the underlying mechanisms and potential confounding variables before drawing causal conclusions from correlations. Thus, spurious correlations are coincidental or misleading correlations that appear to suggest a relationship where none exists, or in cases where the relationship is driven by an unobserved factor. Hypothesis testing is another fundamental framework in statistics which allows us to make inferences about a population based on sample data. Essentially, hypothesis testing is a structured way to test whether the observed effects or relationships in our data are likely to be real or simply due to random chance. This is crucial in research and decision making because it provides a systematic approach to evaluating evidence and drawing conclusions. For example, in economics, we might use hypothesis testing to determine if a new policy has a statistically significant effect on unemployment rates, or if there's a real difference in wages between genders. In order to do hypothesis testing, we follow several steps. First of all, we state the null and alternative hypotheses. The null hypothesis is a statement of no effect or no difference. It is what we assume to be true until we have enough evidence to reject it. The alternative hypothesis, on the other hand, is what we are trying to find evidence for. It is the statement that there is an effect or there is a difference. Once we decide on our null and alternative hypotheses, we select the significance level, which is shown as alpha. The significance level is the probability of rejecting the null hypothesis when it is actually true. Common values for alpha are 0.05 or 0.01. 0.05 indicates a 5% and 0.01 indicates a 1% risk of making a type 1 error. Type 1 error is when you reject a true null hypothesis. After this step, we calculate the test statistic and the p-value. The test statistic is a value calculated from the sample data that we use to test the hypothesis, and the p-value is the probability of obtaining the observed results if the null hypothesis were true. Finally, we compare the p-value to the significance level, which is the alpha, and if the p-value is less than the alpha, we reject the null hypothesis, and we conclude that there is a statistically significant evidence to support the alternative hypothesis. If the p-value is greater than or equal to alpha, we fail to reject the null hypothesis. This does not mean we accept the null hypothesis, but simply that we don't have enough evidence to reject it. The interpretation of the p-value is fundamental to hypothesis testing. If the p-value is less than 0.05, when your alpha level is 0.05, we reject the null hypothesis. This means the observed result is unlikely to have occurred by chance. If the p-value is greater than or equal to 0.05, we fail to reject the null hypothesis. Importantly, a lower p-value indicates stronger evidence against the null hypothesis. A p-value of 0.01 shows stronger evidence than a p-value of 0.04. Consequently, we need to understand that these concepts will form the basis of our econometric models. Understanding relationships is at the heart of empirical research. When you are ready with these modules and when you feel you are ready to take the assessment, which is in the next section, please proceed to the next section, and after that review, more additional materials will follow for you to review and delve into more details regarding the subject matter of these modules. Thank you.